Hello guys, welcome to yet another wonderful discussion on mathematics. Today I'm going to shift a little bit from physics and we go to mathematics, and we're going to interact with some of the very important topics that you may interact with in terms of your exam. My name is Samuel D. Koidia. So let's keep going. Today we'll look at plane geometry. It's another key topic in math. It is one of the topics that students find it difficult to understand, but today we want to look at it and see how we can apply some of the concepts to your exams. So our subtopics will be angles. We're looking at plane geometry, then we'll look at angles. Then we'll look at types of angles. Then we'll look at angles between parallel lines. We'll also look at the theorems that govern angles between parallel lines. So let's keep going. The first thing we want to look at is what is an angle. You know, it's when you look at two lines, the space between two lines will be classified as an angle. In other words, we want to look at the distance between, or the space between two intersecting lines. The two lines, when they intersect, they form an angle, and an angle is formed between two lines, and these two lines, they will meet at a point, let's say a common point called the apex. Let's call it the apex. So when two lines intersect, they form an angle, and that angle has a measurement. So if we look at, let's say that angle is theta, we want to look at its measurement. So unit of measurement of angles. You know, just like it's a space, you must have a unit of measurement of the space. And when the lines are rotated, they will form that space. And forming that space means I have to measure the space that these lines rotate. And that unit, or the units we use to measure the space between two lines, which is called an angle, is first we take the common unit which we have on our calculators. We have degrees. So we'll look at the angles in a circle. We know that in terms of degree, angles in a complete circle will give us 360 degrees. So one unit of measurement of angles is the degrees. Now also, when we express it in terms of radian circular measurement, it's still inside a circle, we'll find out that there is another unit of measurement called radian. Radian is twice 180, and 180 in radian circular measurement is actually pi. So we can express this 360 in terms of radian circular measurement as also pi. So we have 2 pi, which is a radian. So radian is also another measurement of unit for angles. And we also have grades. Grades are also unit of measurement of angles, and there are 400 grades in the circle. So we will have 400 grades in the circle. So all of them are just talking about how lines are rotated in the circle and the total angle they measure. So the space between two lines is actually what we call an angle. It used to be a very interesting stuff. So let's look at the types of angles you may come across. The first type of angle which you may come across from your junior school perspective, you looked at first, what is an acute angle? If the angle is going to be acute, in other words, the angle is going to be less than 90 degrees. Angles that are less than 90 degrees, we call them acute angles. They are less than 90 degrees. In other words, we have, let's say that angle is theta, and it is an angle that is going to be between 0 and 90 degrees. So any angle that falls within that space, we call that angle an acute angle. An example of that type of angle is 60 degrees. 60 degrees is an acute angle. It's between 0 and 90. So we look at another type of angle, which is also called the obtuse angles. We look at obtuse angle. What's obtuse angle? This kind of angle is an angle that is between 90 and 180. In other words, it lies between, the angle is between 90 and 180. That angle is an obtuse angle. That type of angle will be like 100, i.e., let's say, example, we call it, let's say, 100 degrees. 100 degrees is between 90 and 180. And also, we will look at the third type of angle. We call this flex angle. This is angle that is greater than 180, but less than 360. That type of angle is what is called a reflex angle. It's an angle that is greater than 180 but less than 360. So let me give you the first three types I have already interacted with. First, we said it's an acute angle. What's an acute angle? It's an angle that is between 0 and 90. In other words, angles that are less than 90 degrees. And we have obtuse angle. Those angles are between 90 and 180. Example of that kind of angle is 100 degrees. And we have reflex angles. These ones are between 180 and 360. In other words, angles that are greater than 180 but less than 360. And we also have other types of angle that we want to talk about, which are complementary angles. So what are complementary angles? Complementary angles will always add up to 90 degrees. Any complementary angle will always add up to 90 degrees. In other words, let's say this is x and this is y. So when I add x and y, I can always get 90 degrees. And the complement of 30 degrees is actually 60, because it is 60 that we complement the 30 to give us 90. So those type of angles are called complementary angles. They complement each other. So this is a type of angle that is summing up to 90 degrees. We also have a right angle triangle. This is a right angle. Right angle is exactly 90 degrees. This one is a right angle. This one is exactly 90 degrees. Exactly 90 degrees. So angles that are exactly 90 degrees are called right angles. Right angles are always 90 degrees. And we have already looked through the basic types of angles that we want to interact with. First, I'll go back there. The first one was acute angle, which is angle that is less than 90 degrees. And we also looked at obtuse angle. Those angles are between 90 and 180. We have reflex angles, which are also angles that are greater than 180 but less than 360. And we have complementary angles. These angles complement each other. Then we also have right angle triangle, at right angle as it goes like that. So we can go back to the angles between. We have looked at the types of angles. Now we'll look at the angles between parallel lines. First of all, we have to describe what is a parallel line. So I just get that for you, and we see what is a parallel line first. So what are parallel lines? So let's say, what are parallel lines? So properties of parallel lines. These are lines that are moving in the same direction. Let's say this line is AB and this one is CD. They are moving in the same direction. That's one property of a parallel line. And these lines will never intersect. In other words, parallel lines never meet. And their gradients are always the same. There's three properties of parallel lines. The lines will never meet, and the lines are moving in the same direction, and these lines, they have the same gradients. When one's lines behave like that, we call them parallel lines. And we have a major line that is also called a transversal line. What is a transversal line? A transversal line is now a line that passes through or cut across two or more parallel lines. This transversal line is cutting across two or more parallel lines. This is called a transversal line. Transversal line. So again, we have looked at technical points. We said angles are spaces between two lines, and these two lines, when they intersect, they form the angle, and the angle have unit of measurement. We say we have degree, we have radian, and we have grades. Now we looked at the types of angles. We said acute angles is less than 90 degrees, obtuse between 90 and 80, reflex between 180 and 360, and complementary angles will sum up to 90 degrees always. And we have supplementary angle as well. Let me go back to the sixth one. Supplementary angles. Supplementary angles sum up to 180 degrees. So we look at that. So let's say I have an angle there and another angle here. So since they are on the same straight line, when I add up these two angles, they will always give me 180 degrees angles on a straight line. So we call them supplementary angles. So I've just given you a couple of type angles that you need to know before we interact proper. So we have acute angles, obtuse angles, we have reflex angle, and there's complementary angles, we have supplementary angles, we have right angles. So you now know all the types of angles. So we'll go back to our theorem proper. Now to look at the angles that are formed between these lines. There are angles that are going to be formed between these lines. Angles here. Let's say there will be an angle here, there will be another angle here, there will be another angle there. Let's say, and you have another one there, another one there. let me just put them like this. This is, so I have these angles that are formed between these lines as they intersect. Now there are theorems that govern the operation, the relationship between these angles. We have already looked at parallel lines, we've looked at transversal lines, and as I put across the parallel lines to form angles, because the lines are coming to intercept, these angles will have relationship, and we have to establish a relationship between them. The theorems that govern the operation of this angle is what we want to go to as the next. So we'll look at the theorems that govern the operation of lines, angles between parallel lines. So the first is what you have studied from your junior school. It is called the angles, the corresponding angles are equal. So we will look at angles that occupy the same position on these two lines. We call them corresponding angles. So look at this. We have A up there, and A and B are occupying the same position on this parallel line. So we call them corresponding angles. So first theorem is going to be corresponding angles are equal. Corresponding angles are equal. What are corresponding angles? The angles that occupy the same position on the two lines. We give you a corresponding situation. So check this out. You have A there and B there. A is on top of the line, B is on top of the line, C is under the line, and J is under the line. So if we want to correspond them, we can say A is equals to B. We have C is also equals to J, and equally E equals to D, and D equals to E. So let me put here, this is F, G. So I can say D equals to G and E equals to F. So these angles correspond. This A correspond to B, C correspond to J, D correspond to G, and E correspond to, in other words, if A is 60, this B must be 60. That is the relationship between that angle formed by the interaction of those, intersection of those lines there. First theorem is that corresponding angles. You now know what's corresponding angles. Number two theorem is alternate angles are equal. Alternate angles are equal. Are equal. So alternate angles, you also call them Z angles. How do I know they are alternate? If you see the lines interact like this or in this form, you've now look at it. And to establish this concept, you must always ensure that there are arrows on this line to tell you it is the angles formed between parallel lines. These concepts are actually applied on lines, angles formed between parallel lines. So check here. This is, let's say in this case, I can just put E there and B over there. So E and B are alternate to each other. So they are equal. If E is 60 degrees, B must be also 60 degrees. So I can also stretch it the other way. I can fix C there, like there, and I fix G there. So C and G are also alternate. So alternate angles does not only look like this. You know, when you look at this, it looks like capital Z, so capital Z. So we call it, and look up in another form, we call it the Z angles effect. In other words, the alternate angles are equal, means that Z angles are equal because it looks like Z. So we call it Z angles are equal. Number three is co-interior angles are supplementary. Co-interior angles are supplementary. Remember, you already know what is a supplementary angle. Supplementary angle will add up to 180. So when I say co is the same. So angles in the same vicinity are going to add up to 180. That's the meaning of co-interior. So angles that are inside the same space. Let's say this. Like if I look at this diagram, I have E and G. They're in that same space. E and G, they're in that same space. These two will always add up to give me 180. That's the meaning. If I look at the other space over there, that is another interior space somewhere there. This angle is C. This other angle is B. So B plus C will always add up to 180. That's the meaning of co-interior angles are supplementary, meaning the two angles will always sum up to 180 degrees. Now we have the third one there. So we get the fourth one, which is adjacent angles are supplementary as well. Adjacent angles are supplementary. In short, meaning they add up to 180. Now that is what we call in short angles on a straight line. So this, if an angle is like this and here C, so if I look at this, this is A plus B plus C must give me 180. angles on a straight line. They are on the same straight line. If I consider this diagram, I can see that A and C are on this straight line. They are also supplementary, meaning A plus C must be equals to 180 with reference to this diagram, or A plus D is also 180 reference to this diagram, or C plus E is equals to 180 reference to the same diagram. B and J is also 180. Then we can also go this way, F and J, F plus J will give you 180. This is G and F will also give us, G and F will also give us 180. So we'll have a lot of 180 supplementary angles here in this interaction. So because there are lines here, this is a straight line, this is a straight line, this is another straight line, this is another straight line, straight angles on the straight line are supplementary. That's what we call adjacent angles are supplementary. In other words, they add up to 180. So we've got number 4. Now we'll look at angles that are meeting at a point. Let's say there. So angles that are meeting at a point, let's say I have that, I have this angle here, I have this, F, but they meet at a point. So all these angles, when I sum them up, they must give me 360 degrees. So A plus B plus C plus D plus E plus F must give me 360 degrees, or 2 pi. Remember that? That is the angles in a circle. Angles at a point, they're all acting at one point, all of these angles. So all of them we add up to 360 degrees. That is what we call the angles at a point theorem. It is the next theorem that we're going to look at. So now we'll look at the fifth one. We have already looked at so there's another one we're going to look at, which is the alternate, the vertically opposite angles are equal. Vertically opposite angles. Opposite angles are equal. Vertically opposite angles are equal. So watch this out. Now it means that for as much as these angles are meeting each other, they are opposite each other, they must be equal. This is telling you that M is equals to N. Let's say there is A here and B here. So A must be equals to B. So looking at these theorems, this is vertically opposite to this. So if this angle is 60, this one N also must be 60. If this is 30, this must be 30 as well. So they are vertically opposite angles and they are always equal. So I have to give you a summary of what I've said so far. First type of, we have already looked at the types of angles. We went through acute angles, right angle, we went through obtuse, reflex, went through complementary, supplementary angles. Now we came to parallel lines. We said parallel lines are lines that will not meet, they will never meet. They are always moving in the same direction and their gradients are the same. And now if I cross a line, I pass a line through two parallel lines, I'm going to call that line transversal line. And for as much as angles are formed when lines intersect, since the transversal line is coming to cut across these parallel lines, then there are angles from there. So what's the relationship between those angles that are formed between those lines? We want to look at the relationship between them, which one is equal to the other. So we look at the basic theorem. First theorem is corresponding angles. We say corresponding angles are equal, meaning that angles that are occupying the same position on these two lines are always going to be equal. If you look at A is on top of that first line and B is on top of the same the second line and on the right hand side. So A corresponds to B and C corresponds to J, E corresponds to F, D corresponds to G. It's a very important concept. Corresponding angles are equal. If I want to compare Africa to, or let's say a country to another country, I can see the state house is occupied by the president of that country, and the other country also, the state house occupied by that president. So we can say the two presidents are corresponding because they occupy the same position in that particular, in the two countries. So angles that occupy the same position on these transversal lines are called corresponding angles. You know that already. Now we look at alternate angles. We also call them Z angles. Angles that are alternate to each other are always equal. They form the letter Z. Their interaction looks like Z, so we call them in short Z angles or Z angles. This angle must be alternate to this. If B is 30, this is 30. If this is 120, this angle too is also 120. So Z angles are always equal. Second theorem. Now we look at the third one. It's co. Co means the same. Co-interior angles are supplementary. Co means the same. So angles that are inside the same room, in other words, angles that are inside the same space within these transversal lines, like this is a space that is occupied by this angle and this. The two of them must add up and give me 180. If this angle is 50, this must be 130. If this is 50, this must be 130, so that the two of them will add up to give me 180. If this angle is 60, this must be 120, so that the two of them will add up. They are in this space. They are co-interior angles are supplementary, meaning they add up to 180. Now we have already got that adjacent angles as also supplementary. Adjacent angles are what we call in junior school the angles on a straight line. Angles on a straight line are also 180 when you add them together. Now we look at the next theorem there, which is angles at a point. Angles that converge at a point, all of them must always add up to 360 because they are acting at a common point. So angles at a point will always give us 360. And we'll look at the final one, which is vertically opposite angles are equal. And vertically opposite angles are equal means that the lines must cross each other as straight line. Note this concept is actually, this particular concept is misunderstood by the student. It is not the two lines must not break. The two lines that are coming to intercept must intercept as straight lines. They have to intercept as straight lines, not one coming to, you know, that one is slanted there and you say this angle is equal to this angle. No, these lines must come as straight lines before you apply that theorem. The theorem says vertically opposite angles are equal. So now in summary, I've just given you the theorem or the tools we are coming to use. But before we enter into the questions properly, we want to look at some of the technical points that you need to understand before you actually attack the questions. One of the technical points that you have to look at if you want to interact with this is there are other concepts that relate to this, because these are all geometric shapes. There are other concepts that relate to get to this. Remember, we said when we are doing polygons, we said that a polygon is a closed plane figure that is bounded by straight lines. But for as much as we are talking about straight lines here, so we expect these straight lines to come together to form a particular type of polygon. So you'll be seeing that the structures in there. So let's say, for instance, I have these two parallel lines, I have the transversal lines. Now it is possible that I can draw a line here, so a polygon can be formed inside here. A polygon is a plane closed figure bounded by straight lines. So now this is a line, this is a line, this is a line. So I've got a triangle in there, which is a three-sided polygon. So there are concepts that are connected to this plane geometry that are also related to the angle properties of triangle. So we want to look at the angle properties of triangle. So some angles are formed, and when the lines intersect together, they create structures. Those structures are geometric shapes which are coming together. And we say when lines come together, they are going to form a plane structure, which we can refer to as a polygon. So one important polygon that can be formed right here is the triangle. So let's look at the angle properties of triangle first. The first theorem that we connect here is that if I have a triangle like this, then I have an angle somewhere here, I have another angle there, and there is an outside angle here. We call this an exterior angle. So one theorem that connects this is the sum of opposite interior angles of a triangle is equal to the exterior angle. So this concept must be understood because we're going to apply them as we start solving. The sum of opposite interior angles, this is inside and they are opposite. When I add this, they are going to give me that angle over there. In other words, this, if this is 30, this is 30, this angle outside here, or this is 60, 60, this angle must be 120. That is sum of opposite interior angles is equal to the exterior angle. This one theorem you have to master because it is part of this. We are going to embed them into the question, you see that? And we'll look at isosceles principle as well. If I have the same polygon and I have two sides of the polygon equal, we call this kind of triangle isosceles. And because it's an isosceles triangle, it has its own basic principles or fundamental principle that you have to attach here. It means that the base angles must be equal. If this angle is x, this guy too must be x because the sides are equal. So this concept will be inside this transversal line. We can place something here and ask you to find these angles in between here. So it is telling you that when you see a stripe on it, two stripes, it's telling you sometimes one stripe even, so you know that there are these angles are isosceles triangles, and these isosceles triangles have the base angles that are equal. That is one concept that will be embedded inside here. And we'll look at the other concept about triangles, which is also related to all three sides equal. When the stripes are all on the three sides, it means that these angles inside here are all equal. This type of triangle is called an equilateral equiangular triangle. In other words, it is having the same amount of the same type of angles. All the angles are equal, all the sides are also equal. That's what we call in polygon as a regular polygon. This is the first polygon. The triangle is the first polygon because it's only 3 lines that was joined together to form something, and the polygon is something that has to be closed. So 2 lines cannot close. So it's only 3 lines that will close. So we call the first polygon a triangle. So now this 3 basic stuff will be inside that concept that you have to apply and go. Now let me show you another technique again that will help you to master the question. When I start solving the problem, you will see that these ones apply. Some of these theorems are not written in the books, but if you look at the structure, you'll be able to profile your own way to understand the concept. That's what I do. I tell you the simplest way you can navigate the questions and get it. One of these is to look at the technical points you have to look for to be able to solve. Now you will see that you'll be tested on questions like this. You have shapes. These are lines. Angles are formed when the lines intercept. There's an angle there. There must be an angle here, and these are parallel lines. So once you see shapes like this that look like M, that look at W, these shapes are shapes that are somehow technical. If you cannot unfold them, you can't. You can't just look at them and solve. You have to unfold. You have to apply certain things that are embedded, which is also supposed to be known by the student. So anytime you have a shape like this, you have to assume that there is a hidden line somewhere there. A line is there that is passing through, and that line is what helps you to apply the alternate angles technique and be able to solve. So anytime you have an M shape or W shape diagram, you always have to pass through the line there. That line is there. You are expected to understand that and know that the line is there, and that is one of the ways the students will solve this problem. And again, I have to look at I looked at the questions and profile a technique for you to remember. There is a concept that is not written in the books, but I'll add my own there and see. Now I said there is another way you can understand this properly. When you now assume that the line that have started will continue, and a line that is continuing must have started somewhere. That's a big statement. I said a line that is moving must have started somewhere, and a line that terminates must continue. So this is a concept that the student have to understand in order to navigate through the questions there. A line that is moving must have started somewhere. In other words, a line that is terminating right now must continue. So look at that. I said a line that is terminating here, to you it has terminated. But let's say it was an angle like this. This was the structure. So this line that terminated here must continue. That's what I mean. And a line that is moving must have started somewhere there. So it's a concept that the student has to master so that you can be able to know that these parallel lines do not terminate there. It can project forward. And some of the questions you are expected to make your own projections. And when you make your own projection, that's how you'll be able to apply the rules over there. See, now I said a line that is moving must have started somewhere there, and a line that has terminated must continue. That's a concept that you have to understand. It's hidden, but it is expected from the student to understand that there's a line that's supposed to move through there. And that line is called a hidden line. It also helps you to know the transversal line, because if I draw this, now a transversal line has come through. And because of that, if there was an angle somewhere there, let's say that was 120, and you're asked to find this kind of angle, and this one too, let's say this is 130, so you can see that if you extend that line, you must have got a parallel line that is parallel to this. So corresponding angles will survive here, and when corresponding angles survive here, so here will also be angles on the straight line. I can get that angle somewhere there, and here too I can have the supplement of this angle over here. Let's say that is 50. So because I have these, and I have this triangle, then I can use my sum of angles in the triangle to get an x. But you must understand that this line that stops must continue. A line that is stopping now or moving must have started somewhere. A line that stopped must continue, and a line that is moving must have started somewhere there. That is a theorem that I have coined, and I believe that it can help you out to solve the problem. So now we have got the tools to solve the worst problems now. So we are going to look at the first problem, that is the exam question, West Africa exam questions, and we'll apply this concept we have learned. Remember, I said the shapes are supposed to be completed by the student. In other words, some of the shapes you are supposed to draw your own line, they are hidden lines. Those lines are supposed to be drawn by the student. So we'll start. Keep walking as we move along. We want to now go to the questions.